Hello learners, since you are done writing your final papers, I think this is the right time to share solutions to some of the papers that you wrote. So today I will be doing mathematics paper 1, November 2024. So let's start with the first question there. It says solve for x if x into x minus 3 is equals to 0. This one is quite easy. You first take x, you equate it to 0. That's one of your solutions. Or x minus 3, you also equate it to 0. The question said solve for x, not x minus 3. So we need to make x the subject of the formula here by transposing that 3. So x will be equals to 3. So x is 0 or x is equals to 3. Let's move on to the next question, 1.1.2. It says solve for x if 2x squared plus 1 is equals to 4x, and it says we should round off to 2 decimal places. So what we will do is start by transposing this to that side. Then we will have 2x squared minus 4x plus 1 is equals to 0, right? Then we're gonna use the quadratic formula here, because x is equals to negative b plus or minus the square root of of b squared minus 4ac all over 2a. So you know that this is the a value here, the b value there, the c value there. So we have to substitute everything into the formula. So b is negative 4, so we'll have negative into negative 4 plus or minus the square root of negative 4 squared minus 4 into 2 into 1 all over 2 into 2. So x is equals to, let me put this in my calculator. So x is equals to 1,71 or x is equals to 0,29, and that's it. Let's move on to the next question, 1.1.3. 1.1.3, x squared minus 2x minus 3 should be greater than 0. So this one, what you first have to do is to find the critical values. What are critical values? Critical values are x-intercepts. So this is a function, it is a parabola, right? And it has this shape, concave up shape, right? Why is it concave up? Because you know the value of a here, it's 1, right? Remember, parabola is f of x is equals to ax squared plus bx plus c. So if a is greater than 0, then it will be concave up, and the opposite is true. If a is negative, then it will be concave down. So in this case, this parabola is concave up, and they want the values of x where this parabola is above the x-axis, where it is positive, right? So you can get this type of question again with the functions, right? So you should be aware of this, because if you can master algebra, then functions will not be that difficult. So let's find the x-intercept of this parabola here. So for x-intercepts, we should equate the graph to 0, right? So meaning that x squared minus 2x minus 3 must be 0, right? So we are trying to find the critical values or x-intercepts, right? So we need to factorize this. This is going to be x minus 3 into x plus 1 equals to 0. So x will be 3 or x will be negative 1, right? These are the critical values, the x-intercepts, right? So then now let's draw a rough sketch of that parabola, right? So the purpose of finding the x-intercept is to help us draw a rough sketch, right? So we know that here it's negative 1, here it's 3, right? So this is the x-axis here. So where is the graph above the x-axis? The x-axis is this green line. Where is the parabola above the green line? It's this region here and that region there, right? So the question says you should give your answers in terms of x, because it says solve for x. So what you then have to do is to find the corresponding x values of those yellow regions. So it's this x values here, right? it's this x values here, right? They are the ones that give rise to this yellow region. So but then how do we then describe those x values? These x values here, let's start this side, they are to the right of 3, right? So it means that they are bigger than 3. I get if a number is to the right of another one, it means that it is bigger than that number, right? And these ones are to the left of -1, it means that they are less than -1, right? So that those are our solutions. I move on to the next question, 1.1.4. It says 2 to the 2x minus 2 to the x plus 2 minus 32 is equals to 0, right? So these types of questions, what you have to do is to first break down this one here, right? And also change this one as well. I'll show you how you change both of them. So 2 to the 2x, right? You know that let's start with the first one, right? You know that there's a law of exponent that says a to the m all to the n is equals to a to the m times n, right? So now us, right, with 2 to the 2x, it's here, right? So we need to take it back there, right? But make sure that the 2 is outside. Yeah. So this is how we're gonna write it. We're gonna write it as 2 to the x all to the power 2, right, minus 2 to the 2, right, multiplied by 2 to the x. How did I get here, right? So you know that there's a law of exponent that says a to the m multiplied by a to the n is equals to a to the m plus n, right? You have the same basis. When you multiply those numbers, you will add the exponents, right? So 2 to the x plus 2, it's here. So we're gonna break down the roof and take it back there, right? So that's what I did there. So yeah, minus 32 is equals to 0, right? So 2 to the power 2, that's, I can change it and write it as 4, right? Then you let k to be 2 to the power x, right? So we're gonna have k squared minus 4k minus 32 is equals to 0. Can you see that this is a quadratic equation that we created here? So we then solve for k. I'm gonna factorize it. You also have an option here, quadratic formula, and it's k minus 8 into k plus 4 is equals to 0. So k is equals to 8 or k is equals to -4. Remember the question said solve for x, not k, right? So I'm gonna have to bring back that 2 to the power x and equate it to 8. Also 2 to the power x equated to -4, right? So 8, I can write it as 2 to the power 3, right? So meaning that I have the same basis, I can drop the exponents, x will be 3. That's my solution there, right? Now let's check this one. 2 to the x equals to -4. So 2 to the power x can never be negative. Now let me show you why. 2 to the power x is a function, right? It is a function, it's an exponential graph, and it looks like this, right? It has a y-intercept here at 1. This is the y-axis, this is the x-axis, right? The x-axis is the yellow line, right? Can you see that 2 to the power x is always above the yellow line, meaning it is always positive. Everywhere it is positive. It can never be negative. Can you see here they equated it to -4? So there is no x value that you can put in here that will give you a negative number. So we can therefore say this one has no solution, right? Because there is no x value that I can put in 2 to the power x that will give me negative number. Yeah? So now let's then move on to the next question, 1.1.5. 1.1.5, I have the square root of -2x plus 4 minus x is equals to 2, right? So with questions like this, the first step is to isolate the radical, isolate that side, right? Isolating it means you place it on its own side. So we're gonna have the square root of -2x plus 4. So we can isolate it by transposing this x to the other side. So when it gets to the other side, it's gonna be positive x then plus 2, right? Second step is to square both sides. Once the radical is isolated, then we are ready to square both sides. Hear me, I'm saying you have to square both sides, not all the terms. Some people make the mistake, square all the terms, right, instead of squaring both sides. So this squared will cancel the square root. We'll be left with negative 2x plus 4 on the left hand side. Then on the right hand side, we're gonna expand this using the FOIL method. We will get x squared plus 4x plus 4, right? So now let me show you a quicker method to expand a binomial squared, right? It only works with a binomial, then just the faster method. So when we are here, we then have to solve for x, right? We can transpose everything to the right hand side. So we'll have 0 this side is equals to x squared. 4x plus 2x. Remember, when we take this negative 2 to the right hand side, it will be positive 2. So then we add it to positive 4x, right? That will be positive 6x. And this 4 will just cancel that 4, right? Then we have to factorize the right hand side. So 0 will be equals to x into x plus 6, right? So then when we are here, we can therefore say x is equals to 0 or x is equals to negative 6. Then most students lose marks when it gets to this step, right? This question, whenever you're solving questions that have radicals, square roots, you need to validate your solutions, right? Meaning that you need to check whether this x equals to 0 and this x equals to negative 6, they satisfy that equation. How will we do that? We can substitute x is equals to 0 on the original equation that we are given and see if the left hand side will be equal to the right hand side. So when x is equals to 0, right, so the left hand side is equals to the square root of negative 2 into 0 plus 4 minus 0, right? So this is equals to the square root of 4, that's 2, right? The right hand side is also equals to 2, right? So therefore left hand side is equals to the right hand side, right? It means that x equals to 0 satisfies this equation, so we're gonna keep it. So then now let's check when x is equals to negative 6, right? So this will be the square root of negative 2 into negative 6 plus 4 minus negative 6. This is the left hand side. So it will be equals to 2 times 6, that's 12, plus 4, that's 16. Square root of 16 is 4, minus negative 6, that's plus 6, right? So 4 plus 6 is 10, so the left hand side is 10, the right hand side is 2, so the left hand side is not equal to the right hand side when x is equals to negative 6. So we therefore disregard the solution by drawing a diagonal line across the equal sign here. X equals to negative 6. So our final answer is x equals to 0. This step how validator, you don't really have to show it, but just do it on the side, or you can just do it on your calculator. As long as you validate at the end of your solution, then you are good. So yeah, let's do question 1.2 then. Question 1.2, it says solve for x and y simultaneously. So you have 2x plus y is equals to 3. I can label this as equation 1. And you have y squared plus xy is equals to 2. I can label this equation 2, right? So you can ask yourself, which equation will be easier for me to make one of the variables the subject of the formula, right? So, and which variable will be easy to make the subject of the formula? Making a variable the subject of the formula is that that variable will be alone on its own side, right, of the equation. So me, I can see that equation 1 will be much easier because I can make y here the subject of the formula easy. So from equation 1, right, making y the subject of the formula, y will be equals to transpose this 2x will be negative 2x plus 3. So y is negative 2x plus 3. I can label this newly formed equation 3. Then I substitute equation 3 back into equation 2. I said So meaning that where I see y, I replace it with negative 2x plus 3. We are doing this in order to eliminate one of the variables and be left with one variable to solve, because you can't solve one equation with two variables. So we are gonna eliminate y here, you'll see. So negative 2x plus 3 squared plus x into negative 2x plus 3 is equals to 2. Then we can use that method that I just showed you to expand this binomial squared. You know that the 2 needs to come to negative 2x, the 2 needs to come to positive 3. So negative 2x squared, right? So negative 2x squared, so this will be 4x squared, you know that, right? So yeah, don't confuse it. So you'll have 4x squared, I get it. Then for the middle term, you take 2, you take 3, you take negative 2, you multiply all of them. Negative 2 times 3, that's negative 6, times 2, that's negative 12, times x, that's negative 12x, right? Then 3 squared, that's positive 9, right? Then we distribute the x here. X times negative 2, that's negative 2x squared. Then x times 3, that's positive 3x. Then I can transpose that 2 to that side, then it's gonna be minus 2 equals to 0, right? 4x squared minus 2x squared, that's 2x squared, those are like terms, minus 12x plus 3x, that's plus 9x. Oh, minus 9x, then 9 minus 2, that's positive 7, is equals to 0. Then we can factorize this. We can factorize this or use the quadratic formula. The best way is to use the quadratic formula when it's like this, né? So x will be equals to negative into negative 9 plus or minus the square root of negative 9 squared minus 4 into 2 into 7 all over 2 into 2. So x will be, let me put this in my calculator, 9 plus square root of negative 9 squared minus 4 into negative 4 into 2 into 7 all over 4. So x is equal to 7 over 2, or x is equal to positive 1, right? So these are our x values. Then for our y values, we're gonna substitute this x values back to equation 3. Remember, equation 3 was y is equal to negative 2x plus 3. So I can substitute 7 over 2, then y will be equal to negative 2 into 7 over 2 plus 3. The 2 cancels the 2, negative 7 plus 3, that's negative 4, right? So one pair of the coordinates is 7 over 2 is 2, negative 4. Can also substitute x is equals to 1, then y will be equals to negative 2 into 1 plus 3. This will be 3 minus 2, that's 1. Another pair of coordinates, okay, 1 is to 1. Remember, when you are solving two equations simultaneously, you are finding the point of intersection of those equations, né? So now let's look at the final question, right, or for this question 1, which is 1.3. So 1.3, it says consider, okay, let me do this. It says consider a product, right? Let's call this product Z, for example. Z is equals to 1 plus 1 over 2, or let me just call it P, product, right? It is equals to 1 plus 1 over 2 into 1 plus 1 over 3 into 1 plus 1 over 4, right, till infinity, so till infinity, right? And they tell you that the fact that each factor of the product is in this form, right? So we can simplify this first, before simplifying this, right? So 1 plus 1 over n, right? You take the lowest common denominator, which is n, right? So over, then you cross multiply. Remember, this is the same as over 1. So you cross multiply n times 1, that's n. 1 times 1, that's 1, right? So each vector is in this form, is in the form of n plus 1 over n, right? So the first vector, it starts with 2, right? So because you remember they said for n greater or equals to 2, right? So the first value of n is 2, right? So I can substitute the first vector there. It will be 2 plus 1 over 2. That's 3 over 2, right? The second vector is gonna be 3 plus 1 over 3, which is 4 over 3. The third vector is 4 plus 1 over 3. That's 4 plus 1 over 4. That's 5 over 4. Then the next one will be 6 over 5, 7 over 6, you see, etc. Yeah? But then the last term, like we can say the last term is n, right? The position of the last term is n, right? So the position of the last term, we can call it n. So the last term will be n plus 1 over n, right? So what will be the term before the last term, right? So it is one position less than the first term, right? So remember, n represents the position, right? So meaning that the term before the last term will be n minus 1 plus 1 over n minus 1, right? So n minus 1 plus 1, that's the same as n here on the numerator. Yeah, sure. So I can write this as n over n minus 1 into n plus 1 over n. Yeah? So I want you to see this pattern here, right? So for every term, right, the numerator of every term, it cancels with the denominator of the following term. For example, 3 here is a numerator, right? It will cancel the denominator of the following number. It will also cancel that 3 there. 4 is a numerator. It will cancel the denominator of the following number, right? So now let's look at this 2 here. What will happen with this 2? This 2 here, where is its partner? Its partner was supposed to be the numerator before this first term here, right? So you see it has no partner to cancel with, right? So it means that it will remain there. It won't be cancelled. It will remain there. Now you see they will cancel in that order. 6 will cancel 6. Then let's see what will happen at the end. Now n will cancel n, right? So you know that n minus 1 will be cancelled by that n minus 1, that is the numerator at the term before this one, right? So but this n plus 1 here, it does not have a partner because its partner was supposed to be at the following term, right? It was supposed to be the denominator of the next term, but then there's no term that comes after this one. This one is the last one, so it will remain there. So what we will remain with is n plus 1 as a numerator over 2 as a denominator. Can you see that 2 is a denominator there, right? So meaning that the simplified version of our product P is n plus 1 over 2, right? So the question says, for which values of n will this P value be an integer that is bigger than 2, right? So let's do a trial and error. Yeah? Let's substitute a 2, right? Because they said n can be bigger or equal to 2. Let's substitute 2 and see what will happen. We will have 2 plus 1 over 2, right? So that's 3 over 2. Ne? So is 3 over 2 an integer? Because 3 over 2 is 1,5. 3 over 2 is the same as 1,5. This is not an integer, right? So it cannot be part of our solution. Let's substitute 3 then. Let's substitute n as 3. So it will be 3 plus 1 over 2, right? 3 plus 1 over 2, that's 4 over 2, right? 4 over 2 is the same as 2, right? 4 over 2 is the same as 2. 2 is an integer, right? So can you see that all the odd numbers, all the odd numbers of n, right? If n is an odd number, then P will be an integer. Substitute n is 5 there. You will have 5 plus 1 over 2 that's 3. Substitute 7, you'll have 7 plus 1, that's 8, over 2, that's 4. But then when you substitute even numbers here on the value of n, it won't give you p to be an integer. For example, 10 plus 1 over 2, that's 11 over 2, that's 5,5. It's not an integer. So can you see that p, right, I can write this as p is an element of odd numbers, not p, sorry, n must be an element of odd numbers, right, odd numbers where n is greater than when n is greater than or equal to 3, right, starting from 3, right, not from 2. We're starting from 3 because 2 is a what do you call this, it is a even number. So basically n pila is this numbers, is an element of this numbers, 3, 5, 7, 9, 11, all those numbers till infinity. N can be all these numbers in this pattern till infinity. And that's it for question 1.